Thank you. Let's look at web performance kinetosis. A little bit about myself. My name is Eduardo. I'm an engineer at Daddy. I'm a big fan of the open web. I'm also a big believer in open source software. But perhaps most importantly for my talk today, and I very confidently say this, I am not a web performance specialist. I can point you to a lot of people that you should follow on Twitter if you want to learn loads about web performance. I'm not really one of them. I'm more of a web performance enthusiast in the sense that web performance is not really the main focus of my work, it's not my specialty, but it is something that I honestly believe that we as web developers need to get right if we want the web to prosper and to stay competitive against other platforms. We need to be able to deliver reliable and usable and consistent experiences across a variety of devices, regardless of how powerful they are, of how ideal the network conditions are, and where in the world they're being accessed from. And this is why in the past few years I've tried to learn as much as possible about web performance, because I think that this is something that we should get right. So, going back to the title of the talk, web performance kinetosis, there's this funny word, kinetosis, which actually means it's just a formal word to describe motion sickness. And I thought I would be coming up with a really cool surprise for you because, well, in a conference with developers and designers, no one's going to talk about motion sickness, right? Except Gabriel kind of spoiled it. And he actually, he probably knows a lot more about motion sickness than myself, but please bear with me. So, the definition of motion sickness is a condition in which a disagreement exists between visually perceived movement and the vestibular system's sense of movement. So, in a nutshell, the way your brain knows whether you're moving or stationary happens by analyzing information from two different sources. The first one is your vision. So your eyes are constantly sending information to the brain, and if they see like a moving landscape, they're going to tell the brain, well, we're on the move. If they see something like a static piece of paper, then they're going to infer that you're stationary. But there's a second source of information, which is your vestibular system. So somewhere inside your inner ear, you have these tiny canals with a fluid, and as you move around, this fluid will also move because of gravity, and then these tiny hairs in the walls of these canals will be in touch with this fluid, and will also infer things like movement and acceleration. And motion sickness happens when there is a disagreement between these two sources of information. So, for example, a common example is if you're on a moving bus, and perhaps you're sitting at the back, and your inner ear will pick up the movement because the bus will be moving around. So they're going to tell the brain that you're moving. But perhaps you're staring at your phone or at a book, and so as far as your eyes are concerned, you're stationary. And the brain gets these two conflicting signals, and it freaks out. It doesn't know what to do, and that's what causes symptoms like headache and nausea and sometimes even vomit. And so in those situations, what you probably want to do is try to go to the front seat, stare at the road so that your eyes acknowledge the movement, and you sort of eliminate this disagreement and hopefully alleviate the symptoms. And I thought this was quite an interesting metaphor to use when talking about web performance, because I had the chance to work with some organizations of different sizes, where I found this general illness, this headache, shown in the form of poor conversion, low engagement rates, users just abandoning the site very early in their journey, especially on mobile devices. And in some cases, I found that this was caused also by a disagreement between two perceptions, two realities. On the one hand, you have the perception of the organization itself as a closed group of people, which can involve developers and the QA team, project managers and business owners and directors. And all these people obviously use the product and have a perception of how their website is experienced based on their own usage. But then there's a second reality, a second perception, which is the actual real-world audience, the real users of the product, which is, of course, an infinitely larger group of people. And in this second group of people, we can be talking about someone in, I don't know, Sweden, for example, with access to a very powerful device with powerful broadband connections. But we can also be talking about someone in a developing country with a very low-end mobile device on a slow mobile connection. And so these two people will get very different experiences and certainly very different from the first group of people, for the perception that they have. And so I think that it is this disagreement that sometimes is the problem in this organization, because it's not like the organization doesn't have the skill set or the resources to fix issues with web performance. It's more that they don't acknowledge that those problems exist because they experience a completely different perception of their product. And so this talk is about me sharing with you some tips, some processes and some tools that I found useful as a developer in addressing these issues, or at least to start the conversation about fixing these issues in an organization. And I'm gonna sort of separate these into three stages. And the first one is the diagnostic. Do we really have a problem with motion sickness? Do we have a problem with performance in our organization? And to understand this, you need to start asking questions. You need to start asking questions like, how fast is our website? How fast is our competitor's website? And based on that, how fast do we need our website to be? But to answer these questions, we need to put some numbers on fast, right? We need to be a bit more scientific about measuring web performance, because it is a bit more complex than just getting a stopwatch that you start when you click on a link and then stop when something shows on the page. And there are some performance metrics that can help you understand, that can help you have a better understanding of how your website performs and where potential problems might be. So one thing that you could do is you can study some of these metrics. So things like first paint, which is the amount of time it takes between the moment you start the request and you see some things like the first pixel being painted on the screen. Or things like visually complete, which is the time it takes for you to be able to interact with something on your website, like a button or a slider or a select input. Or things like, that's DOM interactive. Things like visually complete as well, which is the time it takes for the page to be fully painted. So once you have a better understanding of these metrics, then you can start and you can do like a more scientific measurement of your website and your competitors, but more specifically your website. You can start looking for potential bottlenecks in your system. And we do this using our beloved developer tools. We love tools, right? And I think there are sort of two categories in tools for finding web performance issues. The first one is so the tools that you find within your browser itself. So most modern browsers ship with very powerful developer tools, and some of those tools provide you vital information to track down performance problems. One of them is the waterfall view, which allow you to dissect the life cycle of all the requests that are going on. So you can identify things like expensive JavaScript computations, for example, that you can perhaps tweak or do in a different way, or render blocking requests that are slowing everything down. Another very useful tool that most browsers include these days is network throttling, which enables you to roughly simulate how your website would be experienced on a different type of connection. So you can simulate how it would work on a 2G or a 3G connection, which can give you some initial idea of how your website could perform in those situations. But even then, this is still a very biased test, because you're always testing from your own perspective, your own computer, your own browser, your own operating system, your own network, even though you can roughly simulate different conditions. But there are a ton of variables in the real world that you're not testing against. And the only way to actually see how the website behaves in the real world is to go out there and test it with different devices in different locations around the world, which, unless you have like an epic budget for travel, in which case I want to work for you, this is going to be a problem, right? And so you resort to tools again. And if you start looking for tools related to web performance, you're inevitably going to come across something called web page test. And web page test is basically a pool of devices scattered around the globe from where you can access your website and then obtain detailed performance reports with all the metrics you can think of about your website. So it effectively means that you have a variety of devices with different network conditions, with different operating systems at your disposal without leaving your desk, which is really, really powerful. And so the next stage, so on the first stage we identified, we learned how can we measure performance and how we can start to identify potential bottlenecks in your system. And now we come to the second stage, which is let's keep our eyes on the road so we eliminate this disagreement in the short term. Let's fix our issues with web performance. And there are no golden rules that you can apply that will magically solve all your problems. But there are some techniques and some approaches that you can try that usually yield good results. Some of these are quick wins, others are not so quick. But you can try things like revisit any render blocking resources. So if you have tons of JavaScript and CSS files that are being loaded at the top of your page, then until they are downloaded and parsed and executed, then everything is stopped, like people won't see anything on the screen. So perhaps you can revisit them, load them at different stages, or load them asynchronously if you can. You can look into removing any unnecessary HTTP redirects. So you know how sometimes you're redirecting from www to not www, or if you're redirecting from no trailing slash to trailing slash. And sometimes, without noticing, you can have a ton of these requests, and these can seriously impact load times. So perhaps you can revisit those and only leave the ones that are absolutely necessary. You could look into optimizing the images that you're serving to your audience. So if you're sending like a 4 meg JPEG across the wire to a mobile device on a 3G connection, that's probably going to be a problem. So you can look into optimizing your assets and ideally serving different assets based on who's requesting them. You can do this in a variety of ways, but if you can adopt some modern web technologies like the source set attribute or even the picture element, then that's ideal. You can also look into lazy loading content. So instead of delivering this huge page load, you can just deliver what's absolutely necessary for a first impression of the page and then request assets asynchronously as the user really requires them. And then you can obviously look into making good use of caching. So if your assets are being cached, ideally on a CDN, that's going to have a very powerful impact as well. So after this, after you go through all these techniques, these and many more, you will hopefully be able to have a plan. Like, you'll be able to say, these are our problems, this is what we need to do from a technical standpoint in order to fix them, and this is roughly how we think is going to take. And this is where you will find an obstacle, usually. Because what you'll be doing is you'll be telling your product managers or whoever is in charge of your team that you're going to need to spend a sprint or half a sprint or however long it takes working on these performance fixes, at the end of which you'll end up with 0 new features, 0 new revenue streams for the organization, 0 new bug fixes, and yet all this resource is going to have to be paid for, right? And that's a bit of a hard sell. And I found from experience that people won't see this as a very good idea. Because this costs money. It does. But so does poor performance. And I think it really helps to frame your argument in a way that is less about performance being a technical problem, but more of a business problem. Because you can actually say that by having bad web performance is costing money to your organization. It's costing customers. And there are a lot of real case examples that you can use to prove this point. So these are just a couple of them. So the BBC reported that 10% of users were lost for every additional second in their page load time. Google DoubleClick reported that 53% of mobile visits were abandoned after just 3 seconds. And AliExpress said that a 36% reduction in load time increased orders by over 10% and conversion by 27%. So these are real case examples of web performance having an impact on the revenue of an organization. And I found that if you start framing things this way, you're gonna have a better chance of convincing people that these issues are worth pursuing. So we're really talking about changing the mindset of the organization when addressing web performance. So we're asking them to think about performance as a feature, and not as a nice to have that you throw at the end of the sprint if you have time. We're talking about considering the implications of something on the web, on the performance of your website at a planning stage, and not just dealing with the consequences as an afterthought. And on this, I really like the concept of a performance budget. And the idea with a performance budget is that you establish a threshold of how long your website can take to load on certain conditions. For example, you can say that we need to load under 2.5 seconds on a 3G connection, for example. And you agree to that threshold, and then every time someone suggests a new feature or a change to your website, you need to consider whether that will have a negative impact on that threshold. And if you come to the conclusion that it does, you need to start asking questions like, can we afford this new feature? And if not, can we drop an existing feature to make room for this new one? So it's really about considering performance at earlier stages rather than just dealing with the consequences later. And so At the end of stage 2, you will hopefully identify the problem, you came up with a plan to fix that problem, you fixed that problem, and you started to see positive results as an outcome. But it doesn't really end there, because what's preventing the organization from going back to the old mistakes? How do you know that you're going to keep your word and stick to those thresholds and to those goals that you agreed on? Well, we need to, and this, I'm probably stretching my metaphor here, but bear with me. So we need to make sure that our bus has windows that are large enough that everyone can see the road at all times. So we need to make sure that we don't repeat the problem in the future. And we need to stick to the plan, basically. And how do we do this? Well, I think it's really important to increase the visibility of performance results. Because if you think about the tools that I showed you earlier, your browser tools, web page test, these are tools that are used by developers. And so you can't expect a business director to be opening Chrome developer tools and looking at waterfall charts and things like that. They won't do that. It's not their job to do that. And so at the end of the day, we developers are the only people with access to performance data, and we are the only people that will have access to how well we're doing in sticking to the plan that we defined earlier. And that's something that we need to change. We need to involve everyone, because if the other people in the organization don't have easy access to this information, that it's not their problem. And we want to make it their problem. And when I was looking at solutions for this, the first one was visibility, so people don't have, non-technical people don't easily have access to this information. And the other problem was that tools like web page test or browsers, they provide you with a snapshot of how well your website is performing at a specific point in time. Like, you request a test now, you get the data back, and that's it. But ideally, we'd have a way of continuously monitoring this data rather than at just specific points in time. And so I started to look at different tools that would solve these two problems, the problem of visibility and the problem of continuous monitoring over singular monitoring. And so I found a couple of commercial tools that do a great job at this. One of them is called SpeedCurve, the other one is called Caliber. They're both amazing tools, but I sort of wondered if there was an open source alternative that would allow us to do this, for free. And there wasn't, so I do what we all do, and I build one. So I built something called SpeedTracker. And SpeedTracker is it's basically a dashboard that contains a series of charts that display continuous information about various performance metrics. It pulls data from different sources. It uses web page test, and more recently, Google PageSpeed and Google Lighthouse as well. So under the hood, this is like a centralized API, which you can host yourself in your infrastructure, or you can use a public version, which is available for free. And then this API will request tests from web page tests on your behalf. It will get the data back, and it will store it and display it in these charts. It allows you to configure performance budgets. So you can define a threshold for any of the metrics that is supported by a web page test, and you can see these budgets on the chart. So you can constantly see how well you're doing based on these thresholds, and you can also configure it to send alerts to your team members whenever you go over those thresholds. You can configure email notifications or Slack notifications. And one thing that was really important to me when I was building this was to make it really accessible for everyone. And I found it that it's not enough to build something that is open source and that is free, but if you build something like this and it requires like this huge infrastructure like a MongoDB database or a powerful server, then it's still not accessible to everyone because people will still have to pay for this infrastructure. And so I had this in mind when I built SpeedTracker, and the end result basically doesn't really require any infrastructure because it runs from a GitHub repository. So as I was saying earlier, this API will get data from web page test, and it'll write it as data files to your GitHub repository, where all the data will live. And then a Jekyll site will keep on reading this information. You can even serve the website itself from GitHub pages. And then a small React application picks up this data and displays it in the charts, which also means that it's fully hackable and customized. You can do whatever you want to it. So these are just a couple of screenshots of how SpeedTracker looks like. So you can configure your metrics. You can see on the graph on the left, we have a performance budget for a metric called speed index. And then at the bottom, you can see like the film strip view that allows you to see how the website looks over the time of the request. So, quick summary. From my experience, what I find useful as a process is to, first of all, find your problem, study your performance metrics, study your website and your competitor's website, look into fixing the problem, so define a course of action in terms of technical terms of what you need to do exactly to address your problems. If necessary, you need to raise awareness within the organization to tell them how important it is to address these performance issues. And then finally, once you do that, you need to make sure that you don't repeat the problem. So look into making your performance data easily available for everyone in the organization. I was very happy to find out the other day that the BBC is using SpeedTracker. But most importantly than the BBC, I found that Jeremy Keith is using SpeedTracker. That's pretty cool. So yeah, that's pretty much it. Thank you very much for your time. And by the way, I don't want to steal any time from questions, but I just wanted to show you this extra slide that is completely irrelevant to web performance. But I found it too interesting not to share with you. So when I was doing some research for this talk, it got a bit ridiculous at some point because I started reading like medical things on motion sickness, and at some point I was curious as to why one of the symptoms of motion sickness is vomit. Like, why does our body think it's a good idea to induce vomit when it gets these conflicting signals? And no one knows that for sure. But one of the theories, or the hypothesis, is that the brain thinks that you're hallucinating. And one of the causes for hallucination is food poisoning. So it just thinks it's a good idea to just throw out any food you have in your stomach to try to eliminate the problem. So I don't know what to take from this. Maybe don't get poisoned, look after your web performance, and yeah, I suppose that's that. Thank you.